Alright, we're going to start off with this problem 3 from the 3-3 assignment. The half and double angle trig identities. Starting with number 2, we're going to do number 2 and number 5. So at number 2, we need to find, use the double or half angle identity to find the tangent of 202.5. So we can rewrite 202.5 as 405 divided by 2. And now we'll apply the half angle identity for tangent, which is the square root of 1 minus cosine of the angle measure, alpha, which is the numerator inside the parenthesis, divided by 1 plus cosine alpha. In this problem, alpha would be 405. And 405 is 45 degrees past 360, so that would put us in the first quadrant. And cosine in the first quadrant is positive root 2 over 2. So we're going to plug that in for cosine of 405. Alright, and then you could just multiply the numerator and denominator by 2 to get rid of the 2's in the denominator. I'm going to change the 1 to a fraction 2 over 2. And then when I add 2 over 2, 2 over 2 minus square root of 2 over 2, I get 2 minus root 2 over 2 in the numerator, and then 2 plus root 2 over 2 in the denominator. When I divide by a fraction, same thing as multiplying by the reciprocal. The 2's will cancel, leaving me with the square root of 2 minus the square root of 2 over 2 plus the square root of 2. Alright, so now I just want to rewrite that as a radical divided by a radical. And to clear that radical in the denominator, we're going to rationalize the denominator by multiplying the numerator and denominator by the square root of 2 plus the square root of 2. When I do, I get the square root of the quantity 2 minus square root of 2 times the quantity 2 plus the square root of 2. And in the denominator, anytime you multiply a radical by itself, you just get whatever the radicand is, which is 2 plus the square root of 2. And now we need to do the multiplication inside the parenthesis. In the numerator, those are conjugates, so the inner and outer terms are going to cancel. When I multiply the first terms, I get 2 times 2, which is 4. And the last terms is negative root 2 times positive root 2, which is negative 2. So in the numerator, I've got 4 minus 2, which is 2. So that leaves me with the square root of 2 over 2 plus root 2. And I still have a radical in the denominator that I need to rationalize. And I will do that by multiplying it by its conjugate, 2 minus root 2. I have to do the same thing to the numerator. Root 2 times 2 is 2 root 2. Root 2 times negative root 2 is negative 2. And then when I multiply the conjugates in the denominator, again, the inner and outer terms are going to cancel. 2 times 2 is 4. And then root 2 times negative root 2 is negative 2. 4 minus 2 is 2. Alright, and that is my, now I can divide both of those terms in the numerator by 2, so this can be further simplified to root 2 minus 1. Alright, and now number 5, we're given that the tangent of theta is equal to negative 14 root 93 over 93. And we're also told that theta is in the fourth quadrant between 270 and 360 degrees. We use that information to find the tangent of the half angle, theta over 2. We need to keep in mind that tangent is sine over cosine. So we're gonna put the numerator as the height of that right triangle, the vertical leg of the right triangle, and then cosine corresponds to that adjacent side, the 93. So we're going to put 93 for the horizontal leg of the right triangle, and then we're going to use the Pythagorean theorem to find the measure of the hypotenuse. So leg squared plus leg squared equals the hypotenuse squared. Once we do all the calculations for the hypotenuse, we get the square root of 26,877, which simplifies to 17 root 93. So that is our hypotenuse. And now we can apply the half angle identity for tangent. And we need the measure of cosine of alpha, cosine of theta for this problem, since theta is in the numerator. And cosine is adjacent over hypotenuse, so for cosine of theta, we're going to use 93 over 17 root 93. The adjacent side of the right triangle over the hypotenuse of the right triangle. All right, so that's the identity, half angle identity for tangent. So we're just going to replace those cosine thetas with 93 over 17 root 93. All right, now I'm going to multiply the numerator and denominator by that denominator so that I can clear those fractions. 1 times square root of 1 times the square root of 17 root 93 is the square root of 17 root 93. And then 93 times 93 over 17 root 93 times 17 root 93 is just going to be 93. Similar calculation in the denominator. 1 times 17 root 93 is 17 root 93. And then 93 times 93 over 17 root 93 times 17 root 93 is 93. Alright, now we need to, I'm just going to rewrite that, or rationalize the denominator of that radical by multiplying it by the same radical that I have in the denominator, which is the square root of 17 root 93 plus 93. Do the same thing to the numerator. When I multiply 17 root 93 times 17 root 93, I get 17 times the 17 is 289. Root 93 times root 93 is 93. And then the negative 93 times the positive 93 is negative 8,649. And again, those are conjugates in the numerator. That's why there are no inner and outer terms, because they cancel. In the denominator, anytime you multiply a radical by its square root by itself, you're just going to end up with whatever the radicand is, which is 17 root 93 plus 93. All right, so simplify the numerator of the radicand. 289 times 93, we'll multiply those, and then subtract 8,649 to get the square root of 18,228. And the square root of 18,228 simplifies to 14 root 93. And I still have a radical in the denominator that I need to get rid of, so to rationalize the denominator, we're going to multiply the numerator and denominator by the conjugate of the denominator, which is 17 root 93 minus 93. I have to do the same thing to the numerator. When I multiply 14 by 17, I get 238. Root 93 times root 93 is 93. And then 14 times negative 93 is negative 1,302. And then we can only multiply rational numbers by rational numbers, radicals by radicals. So we add that, that's multiplied by that square root of 93 in the numerator. And in the denominator, we've got conjugates that we're multiplying, so we just need to multiply the first terms and the last terms. The inner and the outer terms are going to cancel. 17 times 17 is 289. Root 93 times root 93 is 93. And then 93 times negative 93 is negative 8,649. Simplify the numerator. 238 times 93 is 22,134. And then in the denominator, 289 times 93, and then minus 8,649 is 18,228. And we're almost done. All three of those rational numbers, the 2 in the numerator and the 1 in the denominator, are divisible by 1302. So I can divide the 2 rational numbers in the numerator. Well, I can divide all three of those rational numbers by 1302. 22,134 divided by 1302 is 17. 1302, negative 1302 divided by 1302 is negative 1, except we don't write the 1 in front of the radical. And then 18,228 divided by 1302 is 14. And that's our answer, 17 minus root 93 over 14. And we need to go back and check to see which quadrant, what's the sign of tangent in that fourth quadrant. Again, we were told that the angle measure was in that fourth quadrant between 270 and 360 degrees. And tangent is positive in the first and third quadrant. Tangent is negative in the second and the fourth quadrant. So since our angle measure is in the fourth quadrant, that tells us that tangent is negative. So I'm just going to change the sign, put that negative out in the front, which is going to change the sign of the that second term.